The future of medicine, there's an app for that. And in 2011, there were like 20,000 health apps. 10 years later, now they're like 300,000 health apps and wearables and otherables. If you see a problem, find the kid down the street who can build the app for you, and you can start to help shape the future of medicine as well. You don't need to be a doctor, a biopharmacist, or a big tech company.
We did a project a while ago about the past of cancer research. And if you look back, 50 years, 60 years, 70 years, basically cancer treatments were, you get radiated with a toaster and then you go lie down on a park bench. What do you think of as possible with medicine? We've done so much in the last 50 years, but what do you really think is realistic, in terms of, we can do with the human body?
Well, on the cancer side, I'm trained as a pediatric hematologist oncologist, so I've spent a fair amount of time in the cancer space. It's a really exciting era now with immunotherapies coming on board, the potential to do personalized tumor vaccines, but we're still in an age where most cancers are sort of lumped together and people get traditional radiation and chemotherapy that's sort of one size fits all. But we're entering this era, it's a little more data driven. We're going to sequence every tumor at depth and compare that to the underlying patient, sometimes multiple times. So we'll have sort of the genomic signature and the proteome of the cancer. We'll be able to sort of use and build the digital twin of a cancer patient and really pick the right drugs, combinations, and dosing. Some will still be traditional chemotherapy. Some will be these new oncolytics or immunotherapies. So we're in an age of, I think, of redefining cancer. At the same time, it takes, reinventing clinical trials in the pediatric cancer space. That's where we really learned to cure many leukemias in the 60s. That kind of model of trying to pull people into clinical trials so we can learn from every patient is hopefully going to be the way forward in cancer and many other diseases. So an exciting time, but still cancer is a huge burden on many individuals in society, and we have a long way to go.
There is a lot to sidewalks in a community. People who have sidewalks and can walk in the community leads to better outcomes. So again, there's a lot of sort of setting the playing field for people to live longer, happier, healthier lives. Do you see that kind of movement coming in where we try and think through some of those things?
Yeah, a lot of it is like almost bringing design thinking to health and to medicine. I mean, many hospitals are not great environments to get sleep or to heal in. Many homes aren't set up for aging in place, or communities with walkability and parks and clean water. So all those have, a huge role to play. And there's several groups and other folks trying to design better clinical spaces as well as communities. In Lake Nona, Florida, they're building a healthy community where you've got access to health, but ways to design the community and clinics for all ages. When you mix populations, young and old together, they do better. We all know the challenges of social isolation, which is worse than 2 packs a day of smoking. So I think how you design your society and your communities can play a huge role in the sort of big public health space, as well as to mental health and beyond.
You mentioned Huntington's. Have we had any bright spots in Huntington's in the last few years? I'm not aware of them, but I'm not that in touch with it. But it's one specific gene. If you just have it, you're going to get it. It's just a question of time. Have we done anything to interrupt the flow of that gene?
Well, that's one of the early diseases where the gene was discovered, and you could test the individual. A lot of ethics, like, do you want to know if you have a 50% chance, what would you do differently? When up until recently, there's not much proven that you could do. I believe there are a few clinical trials ongoing looking at some specific targeted approaches. I don't know that anything's been published on that yet, but that's an example where you can target something, and we have seen some pretty significant success in simple diseases like sickle cell. So I'm a pediatric hematologist oncologist. You see many kids who have bad sickle cell disease, sickle crises, and in some cases we transplant them with the bone marrow of a brother or sister who didn't have the gene, and they go on to have long, healthy lives. But it's quite toxic to do a bone marrow transplant. Now there have been approaches where you can take out the blood stem cells, modify them, and put them back in the patient, and now they have sort of a new immune system without the sickling gene present. And in the future, we'll even see approaches where you can do in vivo gene therapy. You don't take the bone marrow out, you don't need to do a transplant. We'll deliver those genes directly to the marrow, and maybe even cure diseases like HIV in rural Africa with gene therapy without requiring a clinic or ex vivo stem cell manipulation. So I think we're entering an exciting time. And with the ability now for all of us to be sequenced, we're going to have these sort of polygenic risk scores that can, again, give you much better tuning to what you're likely to get. So you might change your screening. You might choose to get that full body MRI, even though it's not really indicated for most of the population. You might choose to get those today expensive blood screenings for cancer if you have BRCA1 or other family risk factors. So it's a time where things are starting to become a bit more democratized and accessible, and can, again, move the needle to proactive, personalized healthcare, not just the sick care side.
What do you think are the conditions that are needed to make sure more people have access? Because these are expensive things, and some of the same communities keep getting hit with some of these diseases that you've been talking about.
What's most expensive is when we don't do good primary care and folks get COPD and diabetes and all the complications of that. I think we can use some of these tools not to be more expensive, but make things more available. I mean, think about all the cheap wearables. I'm wearing like an Oura Ring and I have a watch and a Fitbit and a new little device that measures blood pressure, and imagine that's on the wrist soon of almost everybody with a $20 knockoff wearable from China. That can mean people can engage with their health. The idea of self-care, the fact that we can now look at our digital biomarkers, like I get a sleep score, or I can see my resting heart rate. Imagine you stack all those data layers up and you can see, wow, there's a signature that looks like you might have COVID 3 days before you turn PCR positive. That was a study done at Stanford. Or that your sleep patterns are changing, and that's the sign that you're likely to have a heart attack or stroke in 2 weeks. Or your gait has changed and you're likely to have a fall. So I think these tools can be put in almost everyone's hands. They can have user interfaces soon driven by ChatGPT that match their age, culture, language, incentive models, and could give them, that 80-20, they're almost primary care on their phone. When they have a problem, they talk to the smart chatbot that already knows what their genetics are, what they did last summer, and whether they had their appendix out. So that can start to democratize healthcare. Doesn't mean they'll get the full appendectomy or the hip replacement at good cost, but it means we can start to get people insights into their health and their data. And I know you guys were involved in the All of Us trial, for example, and I think that's a brilliant campaign to understand what do these digital biomarkers and genetics and other things mean across various populations, and how do we start to collect all that and make it useful, not just the data, but new knowledge and insights that you can use at the bedside, the website, or for each of us individually.
You mentioned BRCA1 and BRCA2. If you have BRCA1, it doesn't necessarily mean it's going to become disease. But if you read Time magazine, it makes it seem like you're definitely going to get it if you have it, and people are getting these very radical surgeries. What are your thoughts on what we know versus what we don't know about the human body?
Yeah, I mean, BRCA is just one example of a gene associated with much higher risks of breast cancer and ovarian, and that some people, yes, have gone very proactively to mastectomy or to take out their ovaries. I think, we're going to enter this year of precision oncology and precision preventive oncology, so that if you know you have BRCA1 or other genes from other diseases that we know lead to higher risks of cancer or other challenges, that will be much more about screening. You might get a version of a wearable bra that's coming to market that can detect breast cancer early, not an old-fashioned mammogram. You might look at the digital biomarkers from your voice or breath, or again, a blood or stool, a urine sample that can pick up cancers or other problems proactively, kind of like the Minority Report era of the future. So, it's hard to mention every disease. I just think we'll learn more and more about patients. If they can all join clinical trials of BRCA1, we'll learn what subsets and what other factors play a role that really lead them to develop early cancers, and how to pick them up earlier so they may not need to do those, very extreme proactive measures.
We're seeing a lot of things being done in genetic archaeology now, where people are looking back at this village reacted one way to plague, and now that group of people, their descendants, are not getting COVID because of some adaptation that they had back then. Do you have thoughts about how we're going to look back and try and understand disease, like how Crohn's disease might have been a reaction to something worse a few hundred years ago, and we see these adaptations so that we see this in the genetics? We can look back and get a deeper insight into where they come from?
Yeah, I think there are many diseases where evolution has favored some populations. The classic, carrying the sickle cell gene, not having the full disease, protects you somewhat from malaria. Or folks who have certain allergic reactions now, their immune system is a bit haywire, but they may have done better with parasites. And that's not relevant in most communities today. Also, health is social, and diseases like Crohn's and others can be influenced by stress, anxiety, to the microbiome and what you've been exposed to. I think there's data even now, if you're born by C-section, which is more and more common, rather than the usual vaginal way, you get a different vaginome, a different microbiome in the baby that influences a risk for obesity and diabetes and other challenges downstream. So there's lots of multifactorial pieces. And of course, now in the COVID era, we're in the political determinants of health. What news network you listen to determine we like to get vaccinated or masking. So it's super complex. And I think from archaeology and even today's sociology, we can figure out some of those factors so you can identify them early and not, again, wait for them to bite you.
For a long time, we looked at genomics, but then all of a sudden now we have proteomics, right? Which adds another layer of complexity. Do you think we'll just keep going deeper and deeper into more and more complexity in the human body?
Well, we are in this exponential age of healthcare data, right? 10 years ago, a genome was $10,000. It was $1 million 10 years before that. It will soon be, less than an X-ray or a standard blood test. Let's say a $10 human genome in a decade. And you'll be able to get your microbiome from your mouth and your gut. Your mouth microbiome impacts your risk of oral disease and heart disease, and your gut microbiome impacts many things from Parkinson's to obesity to Crohn's disease. And then there's your base genome, which you might only need once. The trick is, what do we do with all that data? Right now, it doesn't translate. When you see your clinician, they don't say, Jesse, I've got your genome. I'm going to pick that statin, not that one, based on your pharmacogenetics. That's low-hanging fruit. So the trick is to take all these new data, turn it again into insights that are useful and hopefully crowdsourced. Back to that All of Us study. How do we take data from almost everybody, let them donate them? So I'm seeing you as a patient in my clinic. I'm learning from folks who had similar issues, genetics, et cetera, and picking the right proactive prevention or diagnostic or therapy that really matches you rather than a one-size-fits-all approach today. And genetics is just a part of that. I think this idea of a digital twin, almost like a flight simulator for each of us, where we can simulate what's likely to happen based on environment, exposome, digitome, proteome, will really give us a new set of insights. One example, Dr. Mike Snyder at Stanford, who published a study showing the Apple Watch can pick up your COVID early, also recently published not just his wearable data, but every hour he get a drop of blood analyzed, I think for over 3 weeks. And now they can look at multiomics, kind of like a Theranos for real, a drop of blood, giving tons of data. And imagine every year, every 5 years, you get a bit of a full body omics done, and you're really modeled as what's really going to be necessary for you to prevent disease or manage what you have. So it's an exciting era. The trick is who pays for it, how do you plug it into workflow, how the incentives and how the regulatory elements, which often lag the science and the art of the possible.
So was that a small needle on his watch or something that he was able to check, or was he actually doing a full test?
Just a finger, like a drop of blood from a finger. Now you don't even need to go to the lab. There's many things you can stick on your arm and it'll draw, 100 microliters of blood. You can put it in the mail. So you don't need to stop by the phlebotomist in many cases. So,
right.
What we can collect, urine, blood, sweatables, all these wearables are going to disappear into Internet of Things that can detect your vital signs. Voice is a biomarker that can predict that sound of your cough. Is that croup, a cold, or COVID, or TB? The Wi-Fi in your house that can pick up markers of behavior and falls and vital signs and sleep. And I think the clinician of the future, or your chatbot AI doctor of the future, will be sifting through all that continuously to see when you change your baseline. So here's health, here's disease. Where's that transition point? If you see that transition, can you do something to knock yourself back before you end up symptomatic and having big problems?
Can we talk about that relationship between the AI to help us? Because, especially today, people are worried about AI. Can we talk about the positive potential here? Because I think that's important. And also, you forgot to say the dogs. They are helping us sniff out certain diseases or whatever. Do they go into that list that you were saying earlier?
Yeah, I call it breath as a biomarker. So dogs can sniff out lung cancer or even prostate cancer. Or changes in your breath if you have ketosis from diabetes. They can smell that out and be trained. Now there are folks who've made basically nano devices that you breathe into, like a breathometer, and it can predict not if you just have bad breath, but maybe you have early signs of a cancer or metabolic disease. So I think breath is another piece of the equation that we'll use. And sweat to idea of poopables. There's several companies developing toilets that will track your urine and your stool, and do you have blood in it and protein and other things over time that could be early proactive measures. But your question was around AI. Yeah, because now it's overwhelming. I mean, I trained as a traditional clinician. You get the Chem 20 or 40 chemistries. You get your basic vital signs. Now you could have all the wearable data. You could have the genomics, the proteomics, 500 other lab values that it's hard to track and make sense of. So I like to reframe it not as AI, but IA, intelligence augmentation. We're going to need these tools to sift through this and make sense of it and present it to the patient and the clinician in a way that's actionable and that, again, is continuously learning. So AI is going to be a really important layer to make sense of this and connect the dots.
COVID really sort of shut the world down in a way that at least I would not have thought was possible. What were the good lessons and what were the bad lessons in terms of a health perspective from COVID? I mean, certainly cooperation was not great. The wealthy countries hoarded the vaccines, but beyond that, did it push things forward from a health perspective?
Yeah, I mean, back to collaboration and cooperation. Yes, some countries, and certainly there's vaccine inequities, but many folks collaborated and shared data in new ways that are still ongoing. I met many people I've only met virtually through collaborations, trying to build an app for WHO and running the XPRIZE Pandemic and Health Alliance, try to connect dots. And we even ran a rapid COVID testing XPRIZE pretty quickly that came up with some novel solutions. So I think collaboration got catalyzed. What took 10 years happened in 10 weeks or 10 days in some cases. I actually have a TED talk that's, how COVID catalyzed the future of healthcare. And in summary, just like Sputnik sparked the space age, COVID has sparked a bit of a new health age. We obviously rapidly moved into telehealth, and now that's gone, isn't maintained the levels, but now we have more hybrid care. We're now all used to doing home diagnostics, starting with COVID, but soon there'll be other infectious and non-infectious disease tests. And we have telehealth calls that'll be augmented with, medical tricorders and other sorts of data. Obviously, mRNA's got accelerated into clinic, and that will have applications like beyond vaccination for disease, but for cancers and other genetic and sort of synthetic biology approaches. We also, learned how to innovate more quickly in hospitals, whether it was speeding up clinical trials and learning to turn people over on the vents, or ways to do smart interactions with patients who are isolated. So I think there were a lot of positives that came out of it. My hope, being an optimist, is that we'll have more benefit than harm in the long run from some of the lessons of COVID. But still, it's ongoing. We know we still have new variants. We have long COVID, which is a huge issue, and we're not out of the woods. But in a high level, I think it did catalyze a little more exponential medicine rather than the incremental care and innovation that we've seen to date.
It seems like human beings have a strong desire to go to other planets, but the radiation to get there is so extreme. Can the human body live off the planet for extended periods of time? I mean, even though it does seem a bit depressing, I'm not excited about going to live in a lava tube on Mars myself, but other people do find that exciting. But the trip there seems pretty costly. What did we learn from Mark Kelly being up there for a year?
So, as luck would have it, I'm an old space geek. I went to the Apollo 17 launch when I was like 3. I almost got to be an astronaut. I got to the final selection down at NASA. So I looked at some of this, and there's really a ton of ongoing and past research on helping humans survive and thrive and maintain themselves in space. Just in low Earth orbit, we've learned a lot from like the Mark Kellys who've been up for a year. How do you maintain muscle mass in zero gravity? What happens to the immune system, to the eyeballs, to the cardiovascular? How do you create the countermeasures to life in space with zero gravity, or on Mars or the moon, partial gravity? There's ideas of, having a rotating spaceship to do artificial gravity. But yes, on a longer range mission, when we get out of the Van Allen belts, the risk of radiation is high, and there could be a solar storm, which could sort of nuke the spacecraft and knock out the bone marrow of the astronauts. So one idea I and others have had would you send a little bank of your own bone marrow stem cells, put them under lead, and if you were exposed to radiation, you could sort of infuse those and reboot your immune system like we do in a bone marrow transplant. I actually invented a medical device at Stanford called the marrow miner, a way to minimally invasive harvest your bone marrow. So you ever need to bank your marrow, Priscilla or Jesse, we can have that happen for you.
I'm going to get Jesse banked so we can send him out.
Yeah, like you bank your kid's cord blood. It's sort of that idea. Well, you might want to bank your marrow when you're younger and healthier and use it for a potential cancer therapy or regenerative medicine therapy. Other challenges going into I just watched a great documentary about Apollo 8. They went around the moon. They're the first to go around the moon on Christmas 1968. The psychological elements of being on Mars, where I think there's depending on the timing, 8-minute delay between communications, and the challenges of the social elements of health and who do you go with. But radiation is a big one. And, how do you bring medical care, and do you send a doctor on the trip? How do they stay trained? Do they use virtual reality to practice surgeries? There's lots of things that space and space exploration has pushed a lot of technologies that have come to Earth. When Armstrong and Aldrin landed on the moon in Apollo 11, they had an EKG live streamed back to Earth. And it took us another 50 years to be able to basically do that from a patch in your living room. So some of those technologies kind of catalyze home terrestrial health as well.
Today's episode is brought to us by Mars Lava Living. Welcome to the forefront of interplanetary exploration. I'm here to present an opportunity that is as daunting as it is exhilarating. Mars Lava Living. You've heard of Mars, the red planet, of course. Every day you'll wake up with a view that a few have ever dreamed of, a horizon that stretches across alien plains and towering volcanoes, where temperatures can plummet and death storms rage. Your home will be a marvel of human ingenuity. Nestled within a Martian lava tube, how great will it be to live in a tube? With Mars Lava Living, you're not just buying real estate, you're securing a place in history. There's a group of people who would like to transfer consciousness into a silicone body. In other words, leave this mortal coil and have our consciousness in a robot, for lack of a better description. And we certainly see that in science fiction all the time. I mean, do you think that that's ever within our reach, or is it a sort of idealized version? Do you see any experiments in consciousness that explore this?
You're beyond my pay grade, but I would think today you can already make a digital twin of your voice, and we could record all the video of Jesse or any actor and create an avatar of them. And now, of course, the deep fakes are getting better and better, and all the issues that you're well aware of in Hollywood of what's going to happen in the future of entertainment. You could create that avatar. It may seem to use the same language and voice and intonations and ChatGPT-based virtual Jesse. Is that still you in your consciousness? Probably not.
I think that's more of a mirror, spitting back to us our desired recollections of, our view. It doesn't really give us consciousness. I think it's beyond all our pay grades to know whether it's possible, though they're exploring that. Do you think that we can ever communicate with animals? Like, will I be able to wear a headset and talk to my dog, or something like that?
You already do that. You're already talking to your dogs.
Well, I do talk to the dog, and I do think the dog understands. But in reality, if I really examine that, it's like the dog's just wagging at me because of 10,000 years of coevolution. You know what I mean?
So when we get to Dr. Doolittle's the question, well, I mean, already with your pets or your kids when they're babies and they cry, you can already, that's the wet diaper cry, or that's the one I'm fussy, or that's when I'm ready to play. And same thing with some animals. And I know there's several groups, Tristan Harris and others who've done AI work, are like analyzing whales, and they're finding that there's different dialects and that they teach each other language. And we're trying to learn what some of those signals might mean. So it might be that you'll be able to go and talk with the whales and give them watch out for that ship. So I think in the animal kingdom and beyond, we'll probably parse out some pretty incredible insights over the next few years that might enable us to better communicate with them. And sometimes it's, the bees and how they buzz around, and you can simulate that with robotic bees and tell them to go from one hive to another. So lots of exciting, and that's embedded now with AI, big data, machine learning, and gleaning those insights that would be impossible to parse with small data.
Do you think sound plays a role in health? And I'm not talking about like invasive sound necessarily, but just sounds. It's like I listen to rain sounds at night because it's very peaceful, but I wonder just whether it's noisy in my neighborhood or whether that affects me adversely and I'm not aware of it,
Yeah, I mean, there's sound pollution that can affect quality of life, sleep, anxiety. All those things can be spooled up in certain neighborhoods and beyond. There's also music as therapy. We know that every species has music. A small story at my Next Med Health conference, we decided to experiment where we use this app where the app and the camera can pick up your vital signs. And we crowdsourced the vitals before and after music, and everyone's heart rate variability had gone up, meaning less stress, and their heart rates had come down on average. So that's another kind of piece of the equation. So there's something about sound, and people have done sound healing for ages. While I'm a Western trained clinician, I think there's a lot to learn from Eastern and other traditions in medicine, men and women who've evolved what works sometimes over thousands of years, and sound might be a part of that.
I had a project where we were trying to do it was a diseaseome. There was somebody had done some interconnected nodes about how disease worked in the body. And I tried for a long time to say, can you build a Google map of disease? And then could you take a map of, say, Ayurvedic medicine and put it over the top of it? And I was completely unsuccessful because I could not get anybody to just objectively explain what it was, right? It had a moving target all the time. And I know that sometimes, like, if I sprain my ankle, I can do acupuncture, and it's fantastic. You light a match on the end of it, and it spreads warmth right into the place where the problem is. But are these completely different thinking things? Do you see a way that these two different kinds of medical practices can come together in some sort of way?
Well, it's probably often an issue of language. You're calling some disease at different things. It used to be humors, and maybe some are, a metabolic disease that's really tied to your gut health and your brain health. And some of these other systems, Tibetan medicine, for example, looks at things in very different descriptive buckets. And even Western medicine is very siloed, right? We're not connecting the dots. You've got the specialist for, your right knee, your left knee, and your heart, and your brain, and your gut. And so we're very siloed. And I think many other traditions are much more integrated and systems-based care, I think, is starting to come together where, you're not just going to call it diabetes, or we're going to know it's one of 3 distinct genetic subtypes. Or again, we talked about cancer early on. It's not lung cancer. It's one of 5,000 different variants, and we'll be much better at detecting it and treating it. So I think there is an opportunity to study it. In fact, there's examples where groups have gone to the Amazon rainforest, worked with the medicine men and women and said, what do you use for X, Y, and Z? And they've found the plant. They've extracted what was the active ingredient. Some of them have gone on to become actual pharmaceuticals based on that learning. Just like, aspirin came from a plant as well.
Right.
So I think there's lots of opportunity to blend the two. And now everyone's doing meditation and mindfulness and yoga and connection, diet, all can be reversing heart disease and maybe even early Alzheimer's. So we don't need to always be in the give the drug realm. We're moving into even, prescribe the app kind of thing that can affect behaviors, because behaviors are what impacts most of our downstream disease. And now we're in this era where with wearables from the early Fitbits now to the more fancy ones and otherables can pick up almost every element of physiology and behavior and give those personalized nudges and insights to help keep you healthy before our behavior-driven diseases emerge.
The cancer that they were fighting 60 years ago is different than the cancer we fight today because cancer itself has evolved as we design these treatments. the body reacts and the actual underlying cancer changes. So the next battle is, personalized treatments, but cancer is a wily foe and disease is a wily foe. So, when we look back at, Egypt has so many, I want to say millions of graves there. If we look, people were dying pretty much of the same things that they're dying of now. Maybe life expectancy is longer, although I think we've had a reversal on that in the last few years due to COVID. What are your thoughts? Like, can we extend life further when we see the Silicon Valley ideology is that we're going to live forever, but can we live forever? What is the limits of what we can do,
Yeah. I just got off a call talking about super longevity, and I think that's the wrong format. I'm more interested in extending human health span, right? We want to make 120 the new 70. I was actually last December with my wife's grandmother. She turned 104. We're also at her 100th birthday. And she's had a pretty amazing quality of life the last 20 years, partly because of not just hopefully some good genetics and that she spoke 7 languages, but the social determinants of aging, the environment she was in, the school and the stores and the social interaction in her community in Jerusalem. So I'm not one of those folks about super longevity. I think we can now, putting on my pediatrician hat even, start much earlier. The idea that we can be much more proactive and personalized in our healthcare journeys. We'll all soon be sequenced even before we're born. Kind of that Gattaca world's emerging where we can do what's often called precision risk stratification. Not everyone needs their first mammogram at age 40 or colonoscopy at age 55. Sometimes it's going to be earlier or later. And hopefully from the pediatric realm and beyond, we'll start to be more into self-care and preventative and precision health and wellness, not waiting for the cancer to evolve or the diabetes or the neurologic disease. So I think that's where we're going to really move the needle rather than just better ways to treat the cancer once it's stage 3. And back to your prior question, now we're seeing the emergence of companies like Grail and Guardant where you can do a blood test and getting better and better, pick up early cancers where early detection can make a big difference. This potential shift to being much more proactive and paying for health rather than the disease side is going to lead us to these, extended health spans.
I read now they're saying that perhaps your genetics is less than 50% of the outcome of your life. You just talked about a grandmother, 104, social determinants of health. Do we have a ratio yet? And also access to those more positive things that one needs to do to have a better quality of life. And how do we think about that? What are your thoughts about that?
100%. I think there's several measures, but some stats I've seen only about 15% of our health span and longevity is related to technology. And most of it is based on roughly social determinants and maybe even your digital determinants of health. There's that famous quote that your zip code is more impactful than your genetic code in terms of your life expectancy, some zip codes around New York City, especially. And so I think we need to understand the social determinants, but also other elements like the exposome. If you grew up in Beijing or a city with lots of pollution, you're going to have a very different exposome to your lungs, and your risk of lung cancer or other pulmonary diseases will be much different than if you grew up in rural California. So I think there's a real opportunity to understand human connection. The Blue Zones project done by Dan Buettner found that, societies that respected the elders, they had sense of purpose, they had community. Those all, in addition to diet and good sleep and maybe not smoking, all contributed to longer healthy health span. So it's a complicated mix. So nature, nurture, it's not just your genetics. But I think we're entering an era where it's not just your genes we can measure. You can measure your genome, your metabolome, your sociome, your exposome, and start to blend these together. This idea of a digital twin would be much more tuned to what's useful for that individual or community or population. That will really move the needle rather than just the sick care model.
I mean, Daniel, how do you see the next 50 years of biomedical research?
Well, there's that famous quote from Bill Gates that we tend to, overestimate what happens in 2 years and underestimate what's happened in a decade, let alone 5 decades. I think a lot's going to, the last 10 years were interesting. The next 10 years will make the last 10 years look slow. I think we'll see a lot of, not necessarily consolidation, but blending of fields, right? It's not just oncology and cardiology and pathology. We're going to start to blend the knowledge sets because everything is now being understood at the molecular and genetic and omics level. So we'll understand life and disease in that way. I think we'll see a lot more ability to provide the tools to many more folks on the planet to sort of stay proactively healthy and quote unquote younger. In 50 years, I think we will have by then unlocked some of the mysteries of how to stop and reverse the aging clock, and see maybe some disparities like the Gattaca movie and folks who are able to genetically modify themselves and reverse and even have rejuvenative therapies. But I'm hopeful it's going to be one that's not based on our current sick care model, intermittent data, usually only collected in the 4 walls of the clinic, where we're having continuous forms of information collected in safe, privacy-enabled ways that will give us that early warning, that check engine light for the body, that gives you the nudge to find the things super early to prevent it from ever happening. And so it'll be much rarer to have a severe, stage 2 or 3 disease pop up because you'll pick it up at stage 0 or stage 1. We'll have much smarter ways. Sometimes it's a digital therapeutic. Sometimes it'll be a gene therapy. Sometimes it'll be an app or combinations that will nip in the bud. And then, more importantly, we're still in this era where people just hold on to their data. It's siloed. It's not connected. We'll hopefully be a bit of a crowdsourced era of healthcare, not 50 years, hopefully in 5 and 10 years, where we're all able to become data donors and create that Google Maps or Waze for health, where if I'm on a journey here in Silicon Valley, I don't care about the traffic in New York or Paris, but I want to learn from others on the same streets as me in real time. And that's going to start to happen, not waiting 10 years or 17 years from some new data to be published in some study to make it relevant to me or my patient. So I think we'll end in more of a real-time collaborative mind meld. And these chatbots and AI agents will all have our own health care bot of whatever we need in a very low-cost way that will help keep us healthy and find things early and then manage disease when we need it. So lots of layering come together. No more fax machines by 2060.
I want to go to that. I'm going with you, Daniel, to that world. I have a question, though, for somebody who might be a little compulsive. I don't know anybody like that. All of the different wearables, I do get hyper-focused. How many steps, like what I'm eating. And it's just, how do we not be crazy in our effort to be healthy? Like, how do we think, or is there an app for that as well?
I think depending on who you are, there'd be an app. I mean, the hypochondriacs of the world, always checking their pulse or worried that they have got this, next disease. It can help reassure them. I mean, even with the wearables today, it gives me, okay, your heart rate variability is okay, your sleep is okay, your weight's stable, your temperature's not up, you're doing okay. What we're going to see is you'll be able to use and trust that you have a green light that day or a yellow light or a red light, and you'll adjust accordingly. Like even my little ring gives me a score, not just of my sleep, but overall my picture of vitality for that day. And that can be nudging me enough without making me be obsessed. It also can start to pick up problems that I'm not going to be aware of. Your simple wearable can tell you if your heart rate's 120 when you're sitting down, you might have AFib, atrial fibrillation. You might want to get checked out, or it might be a pulmonary embolus. So there's a balance between being hyper-vigilant and trying to track every piece of data, and eventually, we're starting to trust self-driving cars that they'll synthesize and give us the right information when we need it. And that's when we need to take action.
It's interesting that it's you start with Plato and Aristotle, and philosophy branches off in a million directions, and you have Spinoza, and you get all these different people. And in a certain sense, you have that same thing happen with physicians, where you start with, is it Archimedes, where he's a physician, he knows everything about the human body, and then it spreads into a million specialties. And now we're going to lose those specialties, maybe not really lose them all, but for that physician, with artificial intelligence, they'll be able to practice much more intuitively because they have all of this power of data and experience and the histories of human beings that goes all into this, this phone and makes it much easier for them to diagnose. Is that some of the promise of the future?
Yeah, I mean, it's already sort of here. I've got a couple of little things on my desk here. You don't need to be a cardiologist now to use, here's this AI-enabled stethoscope. It does heart sounds and it disattaches. I can probably do it here live if it's plugged in, but it'll do an EKG, it'll listen to the heart sounds, and it can diagnose a murmur on me, and I don't need to be a cardiologist to diagnose that murmur. We can use AI, smart digital tools to democratize diagnostics and therapy. The community health worker in rural Rwanda can now do what a primary care doctor might do at Stanford. So there's going to be sort of this. Here, let's see.
It's okay. We're not giving you a.
There's my I'm not having an MI. But this is not cheap yet. But this kind of thing could be in the digital diagnostic pad of anybody who's maybe a high school education, but they can start to do basic screenings and plug into telehealth and the right AI. That begs the question: who's going to get accepted, and who should be the doctor or the nurse or the pharmacist of the future? Is it based on them being still good at physics and organic chemistry, or should they be able to program apps and have better emotional intelligence? Because we'll spend more time sifting through the data, the insights, rather than trying to be Dr. Welby or what's that guy on TV?
Dr. Kildare, Dr. Marcus.
Dr. House.
Dr. House.
Yeah.
Well, House and Dreamy, all combined.
Just to what you were saying, Daniel, really important though, are medical schools going to have to adjust curriculum, and are they adding in technology, just like with bioinformatics and being able to read data, and are they going fast enough? I think we spoke a couple of years ago with Dr. Topol, who was they're not going fast enough. They're not changing. So what do we need there to get the right people in, the right doctors getting, all of that?
Right. When I run into Stanford medical students and others, I'm still surprised that they almost have the same curriculum that I had 20-something years ago. And it's, still driven by the requirements for accreditation. The Flexner report from the early 1900s finally rebooted medical schools to have some valid training platform, but it hasn't changed so dramatically. Some schools are more systems and disease oriented, but they're not necessarily teaching folks how to leverage apps or understanding, food as medicine or new ways of doing remote patient monitoring. This future is hospital to home or hospital to hospital. How we do hybrid care. It's not all going to be in the clinic or the ER. The hospitals will be full of only very, very sick patients. Most folks will be able to go home with a smart sensor and an Internet of Medical Things homed and be treated for most of what happens in hospital today. So I think we need to rethink medical education. There's tools now like virtual and augmented reality. You can go on a VR headset and practice a surgery as a team or interacting with a difficult patient. So there's lots of ways we can not just do see one, do one, teach one like I was trained, but see one, simulate. And so I think to prepare clinicians to be the doctors of 2045, what they need now might be a bit different. And I don't think curriculums are yet adjusting. How do we integrate genetics into clinical care? Who's going to encourage the clinicians today to rebuild the user interfaces, which are kind of kludgy and drive burnout? Lots of challenges, but lots of opportunities to reboot healthcare.
How do you keep up with it all? I mean, it's such an ever-changing field now, and you're one of the few people I know who, I look to who sort of knows what's happening. How do you stay on top of it all?
Sometimes it used to be Twitter. Sometimes I just, read a lot or bump into smart friends like you. I did have this problem now, like I gave a TED Talk in 2011, the future of medicine, there's an app for that. And in 2011, there were like 20,000 health apps. 10 years later, I gave another TED Talk and now they're like 300,000 health apps and wearables and otherables. So I built a little platform that you and your listeners might want to try out. It's called digital.health. And you just go to that website and we have like 3,000 solutions that are emerged, where everything from mental health to managing your practice to digital stethoscopes to tools for AI-based radiology. There's just so much out there. The challenge is most clinicians are not yet into this digital age. They don't know that they can prescribe an AliveCore device for tracking atrial fibrillation or prescribe a platform for managing type 2 diabetes with diet or a tool that might manage their practice or a diagnostic tool like a pocket ultrasound. So that's a platform I've been crowdsourcing to sort of, help me search and find what's out there. That's one tool. The other is, I've been curating a conference called Next Med Health where kind of I bring together people from all different worlds, from the folks doing psychedelics to CRISPR to chatbots to drones to nanotech to synbio. And when you sort of see that people mix it up from different parts of the world, different fields, that's often where the magic happens. And others gain insights as to what's here and what's coming next and what we can do about that. Because if we're thinking like in 2023 technology, that's not going to build 2033. We need to go, wow, we're going to have the $10 genome. We're going to have next generation mRNA and new gene editing and chatbots and ChatGPT 8. And so you need to build using those convergent technologies, not what's in the tool set today, even though today's pretty exciting.
Well, Daniel, thank you. Thank you so much for coming on. It's good to see you.
Thanks for having me. I was going to say, I would encourage anybody out there listening, when you have a health challenge in your friends or family or yourself, go out there and look for the solutions that already exist, try them out, maybe push them to your doctor to use that connected blood pressure cuff or meditation app. And then if you see a problem, find the kid down the street who can build the app for you and you can start to help shape the future of medicine as well. You don't need to be a doctor, a biopharmacist, or a big tech company.